Fiberforge is a technology company that's commercializing a manufacturing process. And the manufacturing process promises to lower the cost of advanced composites in high volume to make materials more affordable for widespread applications.
The Fiberforge process starts with the design of a part, and in composites there are many degrees of freedom because the strength and stiffness of the part is aligned with the fibers, and we end up using a lot of carbon fiber because it's the strongest and stiffest of the various fibers, so it will lead to the lightest weight parts. And those fibers are combined with a matrix material or a thermoplastic resin. Which fibers we use basically is determined by what the application is, what the cost target is, what the performance requirements are, and what the environmental requirements are. And once the part is designed, then we use software tools that we've developed to convert it into a flat sheet, a tailored blank we call it. And we have an automated system that's part of our patented process to print out that tailored blank, that flat sheet with all the fibers aligned where you want them in the part. The machine can rotate the blank to give you any orientation, any pattern that you want. Following the layup, the part is put into a thermoforming system which has three main stations. The first station is a blank loading station where the blank is fixtured in a shuttle system, and that shuttles into an oven, and then when the blank's at the right processing temperature, it shuttles very rapidly into a press cavity where that then closes and forms the part, and it quickly quenches the blank once it's formed into its final shape.
So you can form a part in about a minute, and that's one of the advantages of the forming cycle of our process versus the competition that are about half an hour to an hour, and that really helps us come down the cost curve. The Fiberforge process is very efficient and affordable in creating a wide variety of products for today's consumers, and here's an example. It's an automotive seat frame made for Johnson Controls out of carbon fiber and nylon. It's a front seat, and it saves up to 40% of the weight over an aluminum seat frame. Similarly, this is a wheelchair backrest made from carbon fiber and nylon. Two very affordable resins. A more expensive resin is carbon fiber PEEK, for this is a helicopter load floor that is as tough as titanium, yet at the cost of aluminum. These are some components also made from carbon fiber PEEK for aircraft. To show you how flexible the Fiberforge process is, this is a glass fiber backpack frame, and here's a carbon fiber variant, and can meet different price points and different performance criteria of the customer. This is a skid plate made from carbon fiber and nylon, and this is a military helmet that we're working on with the Army. The Fiberforge process is amazingly flexible and enables manufacturers to produce high-volume, advanced composites ranging from low-end, low-cost consumer goods to high-performance aerospace and defense applications. Two of the critical design parameters of composites are the stiffness to weight ratio and the strength to weight ratio. And composites have benefits over metals in both of those categories. With a composite, you can orient the fibers along the path that either is stiffness dominant or strength dominant and have a phenomenal increase in stiffness or strength to weight over a metal.
One of the main benefits of thermoforming with the tailored blank is that edge trim can be recycled.
Then the other environmental benefit is when you use these materials in things that move, like planes, trains, automobiles, you take weight out of the vehicle by using a lighter weight structure and save up to 10 times the fuel or 100 times the fuel in an aircraft. So it's a great way to leverage fuel savings by investing in a lighter weight structure. Our process has great cost advantages over the competition for a number of reasons. One is we have less scrap than the competition because our system automatically tailors the fibers where they're needed and where they're not needed. Another way to save cost is how rapidly we can make that preform, because the faster you can make a part, the lower total cost there is in higher volumes. We're basically going to see something like a Fiberforge inside. So many customers will be flying on an aircraft that has Fiberforge seats inside of it, but they won't have any idea of it. We won't have a label on everything that says Fiberforge inside. And then some parts, for example the skateboards that we're working on, that'll be pretty obvious because it'll be a pretty user interactive part that they will see the results of.